Welcome to glazing. What is it? And oh, so much more. First of all, safety considerations. I want you to be smart, be safe, make good choices that will not damage your health. So please make sure you're paying attention and don't do things that's going to cause you damage. Make sure you're not eating or drinking around the glazing areas. Unfired glaze ingredients are often dangerous. There's lots of metals, cobalt, copper, iron, some other ones, manganese. Make sure, again, that you are not eating or drinking around the glaze. This has nothing to do with school policy. This has everything to do with your health. So please, do not just try and sneak food or water. If you are really, really dying, you need to make sure you wash your hands and then take whatever it is you're needing to ingest up by the door on the mat, eat or drink, and then go back to your glaze. So again, do not sneak food. It's very important for your safety. Also, wash your hands before you leave the room. You need to make sure you remove any trace elements from your hands. This is also true if you've been handling a pot that has glaze on it that has not yet been fired. Wash your hands. Also, not all glazes are food safe. While none of our glazes have lead, which is good because lead can kill you, there are still some that are not food safe. So you need to make sure that you take a look at the tile boards. If it's got a red dot next to the tile, it is not food safe, meaning do not use it on dinnerware, cups, plates, bowls, that kind of thing. So again, make sure you take a look at that. I think there's only two, butter blue fleck and sea green pearl, but take a look at it just in case. And it's also a good idea to read the label on the glaze containers just to be safe. You don't want to poison yourself or someone in your family. You need to be aware, glaze is not, oh, that's a typo there, that's going to bug me. Pretend that says glaze is not paint. It is not the same. Glaze works due to chemical changes that occur when we're heating it in the kiln. When the glaze heats up, chemicals react to each other, they melt, they fuse, they bond, and a lot of times the colors change, the surface changes. It looks totally different after it's fired than it does beforehand. Paint is just pigment, whatever that might be, and the pigment that's in paint does not need to withstand 2,000 degree temperatures. So it may be something from berries or something, it's just a pigment. And it's in a binding substance such as latex or oil. It is not the same. It's not a chemical reaction that's occurring. It's just a pigment change. Glazes do not always mix together to make colors the way that paints do. Some glazes layer and are just fabulous. Some do not. Some glazes, it's possible you could have a green glaze result from a blue and a yellow glaze mixed, but there's no guarantee to that. If you mix a yellow and a green paint, it will make green. But in glazes, it depends how the chemicals react to each other. It's not just mixing those pigments, it is different. So a little more on what are glazes. Glaze is a glass-like coating. We apply that coating so that it's both more aesthetically pleasing, looks better, and it's more functional. It makes the pot more impervious to liquids and chemicals and acids and things like that. So it has a twofold purpose. Aesthetics, how good it looks, and functional, how well it serves its purpose. So again, glaze makes the pottery more watertight. Now unfortunately, ours does not become 100% watertight. So just something to think about there. Glaze is primarily made up of silica, which is a chemical that's around everywhere. Sand is primarily silica. Now there are other ingredients used, and those other ingredients control certain characteristics such as opacity. That's how much you can see through it. The color is obvious. Surface quality, is it going to be matte? It's going to be a glossy color. The flow, which means how much does it melt and move while it's melting. If it melts and doesn't move, it has very low viscosity or flow to it. If it moves a lot, it's got a lot of viscosity and it flows a great deal. So a little chemistry there for you. And also to control what temperature range that the glaze is going to be used with. So some are formulated to melt at our temperature, the cone 5, again 2200-ish degrees, and some are formulated to fire to cone 10, which is much hotter. Silica by itself is not really going to work very well for glaze because it melts at such a high temperature. So we need to add other things, fluxes, to lower that melting temperature. Other ingredients that may be included, if you've taken chemistry, these are going to look very familiar to you. Calcium, potassium, those are both fluxes. They lower the melting temperature of the silica. Magnesium, boric oxide. Boric oxide actually can be a glaze all on its own for very low fired things. Strontium, there's all kinds of things. If you ever want to check out the periodic table, ooh, I should add that in there. That is a possibility. So I can show you where on the periodic table all the stuff is. These will be materials, those chemicals will be in materials like bone ash, dolomite, Gersley borate, which there's a funny story about Gersley borate, but I won't burden you with that now, and Fritz, which are glaze ingredients that are pre-melted, ground down, added into glaze, and then it remelts again in the kiln. Our glazes, the ones we use in this room, are formulated to fire at cone 5, which is what our kilns go up to. Some kilns can go up to cone 10. Ours only goes up to cone 5. So after that, it damages the kiln if we go up hotter. It also is formulated to, for the most part, work in oxidation atmospheres or oxidation kiln firings. Oxygen is present the entire time. We'll talk a little more about that later. And also to fit clay bodies or types. Potters talk about the clay body, and we're talking about the type of clay that we're using. So what clay body are you using? Well, I'm using a cone 5 oxidation. There you go. So mature means that it's at its most vitrified, which is the most solid that it's going to be and the most watertight. Some glazes, by contrast, are formulated to fire at higher temperatures or lower temperatures. Elementary schools usually have glazes that fire to cone 05, so that's closer to 1900 degrees, and then a lot of colleges or independent potters fire to cone 10, which is again much hotter than cone 5, and they get totally different looks, both the lower fire and the higher fire. We only do the cone 5 so it doesn't get too confusing and people don't get glazes mixed up. Because if you're using the wrong temperature firing glazes, it does not give satisfactory results, and sometimes it can actually ruin your kiln. Some are also formulated to fire in reduction atmospheres, which means that it's usually a gas or wood-fired kiln, something that has a combustible, has fire, where the airflow is cut off once it's up to the temperature. And then once you've cut off that airflow, the flame uses the available oxygen, and then it eventually goes out, the fire goes out, and it reduces the amount of oxygen. Once the amount of oxygen is reduced, sometimes the color of the clay and the glaze actually changes, and sometimes the other surface qualities of the glaze change as well. Raku firing is an example of reduction firing, and I'll show you some examples of those later. The colors in glazes. If you use cobalt in a glaze, it's going to be blue. If the unfired glaze is pink, it's cobalt carbonate. If it's a dark gray, it's probably cobalt oxide. Copper has a variety of possibilities, and if it looks really dark unfired, it's probably, again, got oxide. Oxide is stronger, more potent than carbonate. But copper is really fascinating. In an oxidation firing, like ours, it turns green. But in a reduction fire, with fire, again, the fire that is smothered, it can turn green, copper, red, or orange. And the copper is actually metallic copper in things like raku. So it depends on the type of firing that's done. Manganese gives you kind of an eggplanty purple. It's a little grayer than that, but it does give a purple. And iron usually equals browns. Now, gold, if used appropriately, can actually turn red. I can't tell you exactly what ingredients are in any of the commercial glazes that we buy, because they don't tell you, but these are some of the possibilities. Sometimes you're going to try and combine different glazes. You're going to layer them, mix them together somehow. But layers can work beautifully, kind of like an ogre. They have layers. Shrek, anybody? All right. So some glazes mix together very well. Some do not. Some are just fabulous together. Some are not. Some make really gross things happen, but some glazes are just fabulous. For example, if you apply robin's egg to your pots and then you put amethyst matte over top, it is really beautiful. Amethyst matte by itself is just kind of pasty and weird, like some gross tongue. So layered, fabulous by itself, not so much. Robin's egg is almost always good, and there's other things that you can put over those as well. That's, again, make sure that's one of the reasons you want to look through the glaze book or look at the glaze presentation online. Regardless of what you use, write it down or take a picture of the container in your pot. That's acceptable. I do that actually when I'm glazing. I often take a picture of the container along with my pot so that I can remember later, because it seems like you'll remember. But sometimes you don't see the finished product for 2 or 3 weeks. People forget. Trust me, write it down, especially if it's a combination people have not tried. We want to know if it works out. So you have to write it down so that we can recreate it if it's fabulous or avoid it if it's not. So, yay! You finished this part of the glazing demo.